Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. Which of the following isomeric hydrocarbon is most acidic among four? I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. Don't worry, at the end of this discussion you will have everything properly cleared. Okay, so I believe you have tried, so let's start. Now, which of the following isomeric hydrocarbon, isomeric means all have same molecular formula, is most acidic? By the way, whenever the question comes about the acidity, remember the concept. Acidity of a substance depends on the stability of conjugate base. What is meant by conjugate base? For example, if you have a molecule HA, if you remove the H plus, whatever remaining, that is called as the conjugate base. This is my conjugate base. Higher the stability of conjugate base, higher will be the acidity. Means if A minus is more stable, so this proton release will be more facile. Now let's go to the main problem. Now if you look at here acidity comparison, you may think, okay, this is about sp3, sp2 acidity comparison. No, but if you look at option number A, you will think, sir, these two positions are benzylic position. We have studied that benzylic carbon ion because my conjugate base is anionic. So my benzylic carbon is expected to be more stable. Student, wait. Okay, so this is an option. If you look at option B case, how? So if you look at option B, now you have to remove the proton here. Now why? Because the conjugate base. So the conjugate base in this case will be this carbon ion. By the way, double bonds will remain intact. And this carbon ion may have a resonance, means it can come here and it can go there. Okay. Now, why I am specifically drawing this canonical form? Answer has resonance stabilization or aromaticity. Can't I draw more canonical form? Obviously, yes. But that may not have. Actually, that's a time waste for me. I need to finish the video as early as possible. Now, if you look at this part, look at student, this is cyclopentadienyl anion. Okay, and this is aromatic. Aromatic means it is stable. Okay, so this is obviously one option. If you look at option number C, if you remove hydrogen from here or here, you may not have cyclopentadienyl anion. If you think, sir, let's remove proton from here and make a negative charge here, then is it aromatic? Answer is no. Look at these bonds. These are not part of this, it's exocyclic to this. Okay, so it cannot have that much aromatic stability like this. Now if you say, sir, what about this? If you make a benzyl carbon ion, isn't it that much stable? By the way, student, this ring is already stable. Additionally, carbon ion, this resonance of this carbon ion may disturb the stability of this ring to some extent because the aromaticity will be disturbed to some extent. So in this case, this molecule was not initially that much stable, but after the deprotonation followed by resonance, it has an aromatic stabilization. Okay, so in this case, this proton release is more facile compared to all other options. So because of the conjugate base stability, this proton or this molecule is maximum acidic. So this isomeric hydrocarbon is most acidic. But if you get this question in your exam hall, less than 30 seconds, how could you solve? First, you need to understand that it is not simply about the sp2, sp3, CH abstraction, no. And after that, you have to think this by yourself. That's why I choose this problem. It's pretty tricky. You need to think this thing in your mind and check the resonance. Anyhow, could you get some extra stability? Because the rule I told, if the conjugate base is very stable, the proton release will be more facile, and that is the question, most acidic comparison. So from that, you need to find it. There, I believe there is no very easy shortcut for this problem. Okay, so what you have learned today? That acidity of a substance depends on the stabilization of conjugate base, and higher the stability of conjugate base, higher will be the acidity. Remember, I am repeating this statement. And resonance result delocalization of electron, and these result stabilization. And aromaticity, if you look at it, it's a very large amount of delocalization. That's why it causes very large amount of stabilization, and molecule prefers to attain aromaticity if possible during the reaction or any kind of bond breakage or bond making. Okay, so this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.